Cool. So I'll clarify actually something first, which is that I'm an engineering manager at MOO, not the engineering manager at MOO. I wouldn't want it to go to my head. So I'm going to talk about pair programming with you, as he announced. I'll tell you a tiny bit about me. I won't go on too long about it. I'm an engineering manager at MOO. I've been a developer, which mostly in the mobile space for apps, which is where I did a lot of my first introduction to doing pair programming. But I'm slowly starting to get it embedded more and more in the teams that I run here as well. So I think the first thing probably to talk about is actually just to set the ground a little bit with pairing and talk about these things. So we're going to cover what it is with a bit of a definition. We'll cover why we need it. We'll talk about why it works, which is very important. Then I'd like to talk, probably most importantly, about why we're resistant to it and why we don't do it. Then off the back of that, we'll talk about how we can make it work in our teams and with ourselves. So what is it? And this is going to sound a little bit didactic, apologies, because you probably know this already, but it's two people, right? It's nominally one screen. Could be one logical screen, could be one physical screen. You may be pairing with someone remotely. Up to and including 2 input devices. Again, your mileage may vary. But principally, the most important thing is it's one task, right? You're 2 people with one task. So how do you get 2 people to do one task? Because if you've only got one keyboard and one screen, how does that work? Well, pairing, if you've done it in a kind of decent way, you should always have each person in the pairing doing one of 2 roles. One of you is going to be the driver, and one of you is going to be the navigator. Kind of like rallying, hence the GIF. So your driver is responsible for the input and the generation of the code, and the navigator is looking ahead. He's an active observer of the code that's being written and monitoring what the driver is doing. But the real key to this is the fact that they are actually collaborating through this process, right? So let's have a quick look at the definition of collaboration, which simply said is to work jointly on an activity or project. And there's a whole bank of synonyms here. The one I really like particularly is form an alliance. I think understanding that when you're pairing with someone, you're forming an alliance is really important, because you're not 2 people doing a different thing, you're 2 people doing the same thing, ideally in the same way. Now that means an awful lot of communication is needed and an awful lot of cooperation is needed, and we'll come to that in a minute. A very natural question to ask at this point is, we call it pairing, does that mean it's just 2 people? Can you have more than 2 people? So I'd argue no. There's mob programming. Familiar with mob programming at all? Has anyone done that? It's a slightly different discipline. It's not something you do every day for every piece of work. It definitely has its uses. But I think as soon as you add another person into the mix, you exponentially increase the amount of friction there is to communicate and make things work together. And there's a quote from a book by Jean Le Carré, which I really like, kind of explains without me having to explain what I mean by this, which is that a committee is an animal with 4 back legs, right? So any group bigger than 2 is effectively a committee. You might as well have a meeting about the code, not actually code it. So that's kind of your definition of what, right? 2 people, 1 task, collaboration. Why we need it is probably a bigger question. There's 3 parts to that. Obviously, as developers, we want to write better code and have better code in our code base. As a manager, personally, I would like to have better people in my team. And also as a manager, I guess anybody involved in tech wants better processes in their development workflow. So how do we do this? Right, so code in and of itself is a logical and empirical piece of instruction. But the people who write it aren't, right? We have our moods and we have our dalliances and we have our, I don't know even how to express it, traits, I guess is probably a better word. So, you know, you might be a pedant, you might be really into accuracy, you might be flighty, you might be inconstant, I don't know. But all of that's going to make its way into your code at some point. So it's really important when you're doing code, as you probably discovered, to have some sort of review mechanism. This is from Jeff Weinberg's book, The Psychology of Computer Programming, Silver Anniversary Edition, a must read. But he has an interesting point about programmers left to themselves will miss things that they don't want to see. And that's just a very natural human thing. Now, that shows itself up in terms of programming defects, and actually there's some numbers that's interesting and differences between pairing and coding stuff solo, which is that solo programming has 6 times larger bug density than code that's written as pair, which comes from that book as well. I'm not just making that up, same reference. There's another advantage that you have to good code that gets written as a pair, which is that the readability improves, right? When you're working with a pair, and we'll talk about this a bit more in a minute, that the act of explaining your thoughts to someone forces you to organize them more clearly and understand them and explain them to yourself. So your colleague in your pair is kind of your conscience. They're reminding you to document, they're reminding you to refactor, and they're making sure that the meaning is clear. Anyone write Ruby here? Good. They say it's self-documenting, but I don't believe it. So this is probably the biggest reason that I think that pair programming is a massive benefit, which is the merge request stroke pull request process. Merge requests and pull requests, that's a system that's so obviously made by engineers for engineers. Because you're communicating with someone, right? And you're getting, you're reading the code, you're getting the gist across of your thoughts about it. Now, you probably heard this, but from a communication point of view, like 70% of the information in communication is non-verbal. So all you've got is the 30% left in the text with no nuance and no expression, no subtlety, even if you use emojis, even if Jira lets you use emojis. So I think it's really important to try and do anything you can to avoid the sort of natural animosity that can arise in formal meeting situations and inspections. I've seen so many times when problems in the team have come from the fact that somebody's written a pull request and the other person's taken it the wrong way and it's resulted in a horrible argument, and we end up, as a manager, I don't want to have to price people apart, I don't want them fighting. I think there's better ways to do it, and I think pairing is probably the best way to do it. Now from the people perspective, and I've linked to the PDF from this research, pair programmers as developers are 90% more confident and 95% happier in the work that they're doing, which I think is really an interesting stat, because I want the people in my team to be happier, right? I want them to be better people. And I think better people do better things. And then from a process point of view, there's some learns we can take from Lean. We want to eliminate wastage. There's all that time waiting for a code review. There's the duplicated effort around somebody doing it and somebody doing it again, and then you're reworking it and refactoring it. Defect resolution takes considerably less time, and you're not chasing down rabbit holes, right? Doing code that you don't need to do. Someone else is there to yoink you back out of that. Now, in the spirit of truthfulness, it's not totally true to say that every single stat around pairing is better than doing it solo. And probably the most obvious one is the amount of time things take. So on average, a pair programming task can take 60 minutes, where it's going to take probably 25% less to do it on your own, because you don't have that overhead of having to explain it. You don't have that overhead of having to go back and rework stuff in the moment. But compare that to the bug density, like a 6-to-1 bug density between solo and pairing. I think it seems obvious that it's definitely worth considering pairing as a practice. Because this is the most interesting bit. This is why it works. So this is to do with a thing called the theory of distributed cognition. There's a guy in the mid-90s called Edwin Hutchins who defined this theory. And basically distributed cognition, as it kind of sounds, is spreading the process of doing a cognitive task across multiple different things, usually things that can represent state. So if you take, for example, imagine you're doing a really fiendish long division sum, and you're trying to do it in your head, and you're trying to carry numbers and iterate through the number. Personally, I find that pretty hard. If you just use a pen and paper, you're distributing the state out to the pen and paper, and that's distributed cognition because you're moving it across different devices. With pair programming, you're of course distributing that state across another person and the computer. And this is a quote from Edwin Hutchins. He says, "Knowledge is commonly constructed through collaborative efforts towards shared objectives, or by dialogues and challenges brought about by the differences in persons' perspectives." And the last bit I find really interesting, because often between programmers, differences of opinion generally generate heat, not light. Where in a pair programming environment, you actually have a kind of because you're both heading in the same direction, those differences of opinion actually add to the process and add to the explanation and add to the code and the quality of it. All of this actually came from shipping. All the original work that Hutchins did was looking at these large ocean-going ships like container ships, and the way that the navigation worked, which was that you'd have many people on the bridge doing individual calculations or individual pieces of information from instruments and sensors around the ship, and all of that would come together to give you a fix and a plot and a course. And he very much examined the state and the way that those people worked together to do that, and the way the state was distributed across all these people on the bridge. This is prior, obviously, mid-90s, right? So prior to the internet and big computery stuff doing this for them. So why are we resistant to doing it? So I hear all the time in the team, would you like to pair on that, or should we pair on that? But they don't always do it, and it is actually not the easiest thing to do always. So I kind of tied it down after some consideration to two reasons. It's fear and pride. Now fear, what you're afraid of? Well, we're afraid of looking foolish. I think that's common to many people. I think a lot of people are afraid of conflict. They don't want to put an opinion out there and then have it shouted down by someone else. It's interesting that people don't always like sharing credit because there is a bit of a worry you're going to lose the recognition for the work you've done. And I have some ideas about that I'll cover in a moment. They might have some fear of their own shyness or introversion. And certainly from a leadership or finance perspective, you can have some fear of not being able to justify having two developers on one task. While it can make sense to us from a technical point of view and from the practice of doing it, it's very often very difficult to justify. Now, from a pride perspective, shorter list, but I think that a lot of people have pride in thinking that they're smarter, and definitely people have pride in thinking that they don't need help. And you do need help because none of us are perfect. As we said, you're going to bring your emotions and your feelings into the code that you write. You can't help it, you're a human being, not a machine. And this distributed cognition theory definitely beats an isolated process every time, right? And if you want a good example of that from the media, is this couple who their success results from the interplay between them, right? Individually, they can be successful, but they're more successful when they're dynamic and there's an interplay of information and discussion between them. So, how can we make it work? And moving past fear and pride. So probably a good thing to do first, right, is to take a baseline and measure. So if you're having problems justifying it, or you're just not sure where the benefit is, like take a task in your backlog, reasonably complex one, and give it to a solo developer and give it to a pair, reasonably evenly matched. Measure it, right? See how long it takes from start to finish. Don't forget to add in any time that you've got to do for a code review for the solo developer, which you might not need for the pair. And then take those results to the team, discuss them, see what people thought. What's the quality of the code that came out? What was the process like? What were the problems that came up in pairing? What were the problems that came up in not pairing? And I think this is always a good one, right? Be public with the results of the things that you find. Encourage the wider tech team or your peers or the internet to discuss what you find. And that's important for reasons we'll come to. The other thing you can do is prepare. This is quite a big change. Having people pair on a, I'm not going to say permanent basis, because it's not always good to do it all the time, but as a base practice of pairing, that's quite a big change to instill in a team. And change will always affect the performance of the team over time. So it's really important to understand that things are going to get a little bit worse, productivity-wise, before they get better and you really see the results of pair programming. And I think that's a lot of why teams don't necessarily get the most out of it or stick with it for very long, because you've got to work your way through this change curve. Has anybody seen the Kubler-Ross grief cycle before? It's an interesting mechanic, I think. It's mainly 5 stages, and it was documented and kind of discovered by Elizabeth Kubler-Ross. The 5 stages are denial, anger, depression, bargaining, and acceptance. And this is pretty much true for any change, not just grief, although she did turn it the grief cycle. But there's always going to be denial about, we don't need to make this change, we're not going to make anything better. Some people get frustrated when change is pushed their way. It can be depressing after a while because you can feel helpless if things you're not used to are different now. Then you can always try and find some room by bargaining for making sure that the change doesn't affect you too badly, but generally you get to acceptance. And the line is usually indicating performance, right? So you're okay at the beginning, right, but you're going to dip down, and you need to know that, and that's why I say be prepared. It's kind of important, I think it was Socrates who said know yourself, to consider yourself and start to get to know other people in the team. Because if you're going to pair with them, you need to understand a bit more about them as people. And if you don't have social connections, what other ways are there for you to understand them? There's a few. A lot of this comes from, I think it's Jungian theory around personality types. So has anyone ever done Myers-Briggs? Right, a few people. That's MBTI, right? Myers-Briggs type indicator, I think, for personalities. There's similar ones called Insights and DISC. They all operate off the same psychological framework. But one of the things they tell you is how you work in a team, how you work with others and how you communicate, how you like to receive information and feedback, how you're most likely to give information and feedback to other people. So in a team, doing an exercise like this and understanding each other a bit more, if you don't, as I say, have social bonds, can really help you shortcut a lot of the communication process. Next thing to do is start considering the environment you're going to work in, because you might want to make some changes to this. Is the desk layout working for people working together on things? Like as you probably saw as you walked in, the tech team's all on this side, right? And we're all on individual desks. And we do pairing, and people move their chairs and things around that, but I don't think it's necessarily an environment that's optimized for pair programming. Some of the teams have actual dedicated pair programming stations where people go and work, and then there is just one screen and one keyboard. And in the same way, like, is the hardware optimized for that? Have you got the right keyboards and screens and mice? You know, do you have, if you have an iMac on everybody's desk, that's not necessarily terribly helpful. Whereas if you've got laptops and screens or more standardized stations where you can move around, that's going to be a help. And as I say, like, defined areas for pairing and solo work. The next thing you can do, or yourselves or help your teams do, is practice, right? Effective pair programmers are going to hone this balance, and you're going to have like initial trial periods where you work together and you do like a retro on how did that go. You know, do I race ahead and not explain something? Do I slow you down by asking you to explain too much? One of the things that you always find with pair programming is there's always an imbalance between the people in their knowledge or skill level. Someone's always going to be learning, someone's always going to be teaching. And I think it's important to be open-minded to that and watch it and document it and talk about it. Shall I wave at the lights? I'm here. Come back on. Have a bit of discipline, right? Agree on a set of mutually acceptable behaviors, and probably more importantly, hold each other to account about this. And some examples. You may choose to slide the keyboard between people. Don't move chairs when you switch roles. Communicate constantly. That's probably really important, I think. Actually, my poor team, this drives them mad. Coming from a pair programming kind of background, all of my team, I get driven mad by the fact that I sit there talking to myself all the time, because I'm always kind of pairing, even if no one else is there. And I talk about my process and articulate it, and I'm not filtering my ideas and discussing it the whole time. Poor people. Regularly make sure you switch roles between each other. So, you know, be the driver, be the navigator. Don't always let the most skilled or experienced or fast typing person be the driver. Give everybody a turn. And this is great, like, take agreed breaks to check mail. You can't just pair all the time, live long every day. You need to acknowledge the fact that there are things that you need to pay attention to. Slack, email, other people, lunch, bathroom breaks, whatever. You can Pomodoro, whatever your choice is, but it's important to take breaks. And as I said, you're not going to do it all the time, right? The sort of mean average is to say, do pair programming about 60% of the time. That's where you get the most benefit out of it. And give people time to go and do individual tasks and go away and think, and then come back to the collaborative group. Okay, so that's it, right? That's everything. Well, probably not. It's important, after you've done all this, if you want to put this process in place, to measure again. Do a retrospect on this, as I said. feed the results into their next sprint planning and iteration. And actually, something that I've heard tell of, but haven't used myself, I think Pivotal recommends you do this. If anybody has any experience with Pivotal, they're very much into XP and pair programming. You can move the assessment of performance to doing it on a pair level, not on an individual level. And that is quite a big change for teams to say, okay, your next performance review is going to be based on the work that the two of you do, not the work that just you do. But if you want to promote, or if you want to really try out this, it's probably worth considering that people respond to reward and recognition in a way that is individual to them. And so if you're going to make pairing work, you need to make the reward and recognition mechanism reflect that. Cool. So let's just review what we went through. What is it? It's two people collaborating on a single task. Why do we need it? To ship better code and be better people? And I didn't update the slide to say, and better processes. Why does it work? Probably the most important piece maybe, that the distributed cognition always beats isolated thinking. We're resistant to it because we're a bit afraid, we're a little bit proud. And we can make it work by listening to and understanding and caring about the colleagues in your team, getting to know them as people and as workers, understanding how they communicate, how they take instruction, how they take feedback, and feeding that back into your working process. Cool. All right, that was me. Thank you very much. My name's Rob. I'm Coca Delacroix on Twitter. MOO.